Okay, so now we're going to work on what I like to call insane madness problems. Insane madness is, well, they're problems that look like they're very difficult, but we like to find easy ways to solve them. Now, my first insane madness problem is not that difficult, but it does have some tricky spots. So the very first thing I want to do is, as always, change the root to an exponent. So I'm going to have sine of e raised to the tangent of x to the 1/2. Now, if you can get through this entire worksheet, the insane madness problems, you can get the derivative of just about anything. So let's get started here. Now remember, we're going to use the Russian doll analogy quite a bit, so if you haven't seen the simpler chain rule videos, you might want to go check those out first. But here what we have is, we want to find the outside function. The most outside function is this guy being raised to the 1/2. Okay, and then inside of that there's another function, the sine function. Inside of that function there is the natural exponential function, and inside of that one is the tangent function. So this is 1, 2, 3, 4 levels of chain rule madness, and so we're going to bust this out right now. Alright, so the first thing we do is the most outside, that's the red one, so we're going to use the power rule. We'll bring the exponent out in front, and remember, you always leave the inside alone. So the inside is sine of e to the tangent x. Okay, and then you subtract 1, so this is to the negative 1/2. Okay, now that I've gotten the derivative of that, I move in one level. And now I'm going to get the derivative of the sine function. Well, the derivative of sine is cosine. Let me put a parentheses here. Cosine of, and you leave the inside alone, as always. Okay, and then you go in one more level, and you have the derivative of e to the tangent of x. Well, the derivative of e, the natural exponential, is just itself, so you have e to the tangent of x because you leave the inside alone. And at last you have the derivative of tangent, which is secant squared x. And that's it. You just open up all the Russian dolls. Oh my goodness. What are we going to do with this guy? This looks very, very intense. But with our Russian dolls, we can do anything. So the very first thing is to identify our functions, outsides and insides. So the most outside function is secant of this entire thing. Then inside of that we have our next function is this guy is being raised to the 4th power. Okay, and inside of that we have the log function, log base 4 of this guy, and last not least we have this guy, the inside of the log. Okay, so but before we continue, I want to make sure that you guys remember the derivative of the log function with a different base than the natural log. Let's just do it here right right now. Remember the change of base formula? Since the derivative of the natural log is the one that I know, I'm going to use the change of base formula to change it to natural log. And so we'll notice the natural log of 4, that's just a constant. So this is really just 1 over, instead of being 1 over x, which is the derivative of natural log, you have 1 over x and then natural log of 4 in the denominator. Right there. And we're going to use that right now when we find the derivative. Okay, so let's get started. First things first, the derivative of secant, I'm going to need a lot of room. The derivative of secant is secant x tan x. Okay, but remember you have to leave everything alone, so this is going to be secant of all of this stuff. So we have secant of log base 4 of x squared plus 3 to the 4th times tangent of exactly the same thing. So it's tangent of log base 4 of x squared plus 3 all to the 4th. Okay, that's just the derivative of the most outside function. Okay, I'm going to need a lot of room here. I don't know if I'm going to run out, but we'll see. We'll keep going. Okay, so the derivative of the inside, which is this black one, is we use the power rule. So we have 4, and we're going to leave the inside alone here in green. So log base 4 of x squared plus 3. Subtract 1, we get 3. Okay, we move one step in. And so we're going to have the derivative of log base 4. Well, we just talked about that right here. It's the derivative of log base 4. This is 1 over, instead of x though we have the inside, so 1 over x squared plus 3, and then on the denominator natural log of 4. Okay, so here that's the green level, and then we move one more in. Now we are at the blue. The derivative of the inside of the log is 2x. And that's it. We've gotten the derivative.